So we need to check f of z is equal to cos hz is analytic or not. So the function is cos hz. We can write it as cos hz is equal to, we know that cos hz is e raised to z plus e raised to minus z divided by 2. And this is e raised to x plus iy plus e raised to minus of x plus iy divided by 2. That is e raised to x plus iy plus e raised to minus x minus iy divided by 2. We can write e raised to x plus iy as e raised to x into e raised to iy. Okay. E raised to x, e raised to iy, we write e raised to iy, we know that this is cos y plus I sin y. Okay. So this is e raised to x cos y plus I e raised to x sin y. Now what is this? E raised to minus x minus iy. This is e raised to minus x into e raised to minus iy. Now we can write it as e raised to minus x. E raised to minus iy is cos of minus y plus I sin of minus y. That is e raised to minus x, cos of minus y is cos y, sin of minus y is sin minus sin y, minus I sin y. Therefore, this is e raised to minus x cos y minus e raised to minus x minus I e raised to minus x sin y. Adding these terms, e raised to x plus iy plus e raised to minus x minus iy, we get e raised to x plus e raised to minus x into cos y is common plus I e raised to x plus e raised to minus e raised to minus x into sin y is common. Therefore, cos hz we can write it as e raised to x plus iy plus e raised to minus x minus y is this term divided by 2. That is cos y e raised to x plus e raised to minus x divided by 2 plus I sin y e raised to x minus e raised to minus x divided by 2. We know that this is cos hx and this is sin hx. Therefore, we can write as cos y cos hx plus I sin y sin hx. Cos hx is e raised to x plus e raised to minus x by 2. Sin hx is e raised to x minus e raised to minus x by 2. So, cos hz we can write as cos y cos hx plus I sin y sin hx. Therefore, our u and v is clear. This is our u and this is our v. Now, how to check this function is analytic or not? We need to verify CR equation. That means ux is equal to vy and uy equal to minus vx. This is CR equation. We need to check this equation for this function u and v, and also check the continuity of partial derivatives ux, uy, vx and vy. If CR equation satisfied and all the partial derivatives are continuous, then this function is analytic. So, u is given by u equal to cos y into cos hx and v is equal to sin y into sin hx. So, for ux, u with respect to x is cos y is constant, cos hx derivative is sin hx Now uy is cos y derivative minus sin y, cos hx is constant. Now v with respect to x, sin y is constant, sin hx derivative is cos hx. Now vy, sin y derivative cos y and sin hx is constant here. Therefore ux is equal to vy and uy is minus of vx. Ux is equal to vy and uy is equal to minus of vx. Therefore CR equation satisfied. Also all the partial derivative ux, vx, uy are continuous. All the partial derivatives are continuous functions. Ux, cos y, sin hx, sin y, cos hx, all are continuous functions. Therefore, CR equation satisfied and all partial derivatives are continuous implies f is analytic. Therefore, f of z is equal to cos hz. F of z is equal to cos hz is analytic function.